So the first thing I'd like to do is to go over our homework from Tuesday. So I would like you to please find the mole work bundle that looks like this. We only had to do the first page. So I want to go over these problems because I did notice some people were struggling with them a bit. These are already set up for you. The first thing I want you to notice is you're starting with 100 grams of water, and then they set up your mole conversion for you. So we know that 1 mole is equal to either the molar mass of a material, or it's equal to 6.02 times 10 to the 23rd atoms. And so for this first problem, we're using the relationship between molar mass and 1 mole. And so this right here is your conversion factor. We are putting grams on the bottom, which is the mass of 1 mole of water, so that way our grams cancels out and our answer is going to be in moles of water. And the relationship there is 1 mole is equal to 18 grams. So when you put that into your calculator, all you have to do is 100 divided by 18, and that means we're going to get 5.56 moles of water. Now the next problem is also using the conversion factor of mass to moles, but notice how it's flipped the other way. And the reason for that is because we're starting with moles. So that means moles needs to go on the bottom. And we know the relationship between any material is going to be 1 mole is equal to its molar mass. And the molar mass of oxygen as a molecule of gas is 32 grams. So what we're doing here is we've got 6 times 32 divided by 1. Moles cancels out. So you just have to do 6 times 32 into your calculator, and you get 192 grams of oxygen. The next one, again, we're using a different relationship this time. So here's our conversion factor. Notice that the conversion factor now is going to be our moles to number of molecules, because that's what we want to find, is we want to figure out how many atoms we have. So the reason that moles goes on the bottom is because we don't want moles anymore. That's what we're starting with. So we're going to do 6 times 6.02 times 10 to the 23rd. And you should get 3.612 times 10 to the 24th atoms. The next one is just asking us to add them all together in order to calculate the molar mass of sodium phosphate. And for that one, you should get 164 grams. Don't forget your units. That's how many grams per mole there are. Now on the next ones, it gives you more of the setup, but you have to fill in a couple more things. So again, remember that the relationships we know is that 1 mole is equal to 6.02 times 10 to the 23rd atoms, or the molar mass of the material. And so if we look at this first one, we're starting with moles. So 1 mole of aluminum goes on the bottom. Well, how many molecules are there in 1 mole? Well, there are 6.02 times 10 to the 23rd atoms in 1 mole. So 6.02 times 10 to the 23rd is going to go on the top for our conversion factor. So we're going to do 6.2 times 6.02 times 10 to the 23rd. And you should get 3.73 times 10 to the 24th atoms. Now the next one, again, it's giving you some of the setup. So we're given 3.5 moles. So that's going to go in our starting position, because remember, always begin with what you're given. And then we have to, we don't want moles anymore. So 1 mole goes on the bottom. And it wants us to find out, and there's actually a typo here, so some of you probably got confused. It actually wants to know how many grams. So we have to find the molar mass of tin, and that's what's going to go on the top, and we're going to do 3.5 times the molar mass. So this right here gets a little messed up. So if you changed it so that you were getting grams, you would have done 3.5 times 118.7, because that's the molar mass of tin, and you should get 415.45 grams. Now, if you went ahead and you instead were like, oh, well, maybe it messed up. If you did 6.02 times 10 to the 23rd atoms, and you kept it as solving for atoms, well, you'd just be doing 3.5 times 6.02 times 10 to the 23rd power, which if you did it that way, you would have gotten 2.11 times 10 to the 24th atoms. So either way you did it is completely fine, just as long as you got one of those two answers, whether you solved for grams or whether you solved for atoms. And then finally, the last one, again, always begin with what you're given. So you're given 90 grams of NaOH. And we don't want grams anymore, so grams is going on the bottom. And we know the relationship of 1 mole of any material is equal to its molar mass. So we're going to have to find out the molar mass of sodium hydroxide. So again, you have to go on your periodic table. Na is 22.99, oxygen is 16, hydrogen is 1.01. Add those all together to get the molar mass, and you should get 40 grams is the molar mass. So now, again, remember, you multiply across the top, and then you multiply across the bottom, so we end up with 90 over 40. A lot of people got the math on this wrong. So 90 grams is what we start with. 1 mole is 40 grams, which means if we have 90 grams, we have 2.25 moles of it. Please make sure to check your work. This video will be posted on Schoology as well so that you can go back over it. There is a quiz tomorrow, so if you need to go back through these and resubmit to get 100% on your homework, please make sure that you do that to prepare for tomorrow's quiz. The next thing I'd like to do is go over yesterday's work. This had a mixed number of problems, so please open up February 2nd mixed problem review practice, and I'm going to go through those. Please check your answers, check your work, make sure that you understand so that you're preparing for tomorrow's quiz. So the first step in A, B, C, and D is to write the formulas correctly. The first one, iron 3 oxide. Iron has a positive 3 charge because that's what the Roman numerals of 3 after it tells us. So the correct formula is going to be Fe2O3, and then we can go ahead and look at the periodic table and calculate the molar mass. So you can see my work over to the left. Molar mass of iron 55.85, but we have 2 of them. Molar mass of oxygen is 16, but we have 3 of them. Add all of that together to get the molar mass. And so you should get a molar mass of 159.7 grams per mole for the molar mass of A. Letter B, dinitrogen tetraoxide. Di means we have 2 nitrogens. Tetra means that we have 4 oxygens. So again, we're going to take the molar mass of nitrogen. We have 2 of them, so multiply that by 2. We've got oxygen, which has a molar mass of 16. Multiply that by 4, and that's going to give us our molar mass, which is 92.02 grams per mole. For tin 2 oxalate, we do need to look up the charges of oxalate. Tin's charge is going to be a positive 2. Oxalate is C2O4 with a negative 2 charge. So our formula is just SnC2O4. And now we can go ahead and use the periodic table to determine our molar mass, which you can see my work over to the left. And when we add all of those different pieces together, you should get a molar mass of 206.72 grams per mole. And the last one for nitric acid, that's going to be hydrogen with nitrate, which is NO3. So the formula for that is going to be HNO3. Again, look on the periodic table, find the molar masses, add all of them together. And you can see my work on the side. You should get 63.02 grams per mole for the molar mass. So double check and make sure that you got the molar masses for those first 4 correct. Now, always remember that when you're given a word problem, start with what you're given. So I am given 0.1 moles of PbNO32. So I don't want moles anymore. So 1 mole is going to go on the bottom, and I want to find mass. So that means I'm going to need to find the molar mass of PbNO32, which should be 331.22 grams. So that's going to go on the top here so that moles cancels out. So I'm going to do 0.1 times 331.22. In green, I do have the cross multiply method if you did it that way. Either way you do it, you're doing 0.1 times 331.22, and you get 33.122 grams. Again, on the next one, always start with what you're given. So I've got my setup on the left in red with the conversion factor, the right in green with the cross multiply method, and you can see that I need to find the molar mass of aluminum hydroxide. So once I fill that in, you can see mathematically you're going to need to take the 20 grams and divide it by 78.01, and you get an answer of 0.26 moles. So again, always remember to begin with what you're given. If I use the conversion factor method, then I need the same unit on the bottom as what I start with. So I want 1 mole on the bottom, and then I'm going to put the units that I want on top. If I want to do the cross multiply method, then I'm going to start with what I'm given, put what I want to find as x on the bottom, and then I'm going to set that equal to my relationship between those two things, making sure I have the same unit on the top and the same unit on the bottom, and then I can cross multiply to solve. So either way that you set this up, you can see you're going to do 0.645 times 6.02 times 10 to the 23rd power. And if you put that into your calculator correctly, then you should get an answer 3.88 times 10 to the 23rd molecules. So the next problem, I've got it set up in red with the conversion factor. I'm starting with liters, and so liters is going to go on the bottom, and I know that there are 22.4 liters for every 1 mole. So you can see that we're going to be doing 14.3 divided by 22.4. A lot of people flipped it around, and that's why you want to make sure that you have it set up with the correct unit on top and the correct unit on the bottom, because otherwise that's how you end up dividing the wrong way. So you're going to be doing 14.3 divided by 22.4. So again, if you like that conversion factor method, if you start with liters, the unit of liters has to go on the bottom. And this is our relationship that we know 1 mole is equal to 22.4 liters. If you use the cross multiply method, then you just need to make sure that your unit on top on the left is the same unit on top on the right. The unit on the bottom of the left is the same unit on the bottom of the right. And no matter what, like I said, you're doing 14.3 divided by 22.4, and that's going to get you 0.064 moles as an answer. Now the next one's kind of interesting. We are given atoms, but we want to find a mass. And if you think about our two relationships, or the relationships that we know, 1 mole is equal to 6.02 times 10 to the 23rd atoms. And we also know that 1 mole is equal to the molar mass of a material. So if we look at these two relationships, that means that 6.02 times 10 to the 23rd atoms is equal to the molar mass of a material. And so if we're given atoms to begin with, we always put what we don't want on the bottom and what we do want on the top. So that means that 6.02 times 10 to the 23rd atoms are in 1 mole of a material. And we know that 1 mole is equal to the molar mass. So if we look on the periodic table at the molar mass of sodium, that means that there are 22.99 grams in 6.02 times 10 to the 23rd atoms. I can also set that up just that same way if I use the cross multiply method, again keeping the same unit on the top as I do on the left and right, and then the same unit on the bottom, and you cross multiply to solve. Now, if you're doing the conversion factor method, you can see we're going to have a little bit more work to do. We're going to have to do 1.98 times 22.99, and then we're going to have to divide by 6.02 times 10 to the 23rd. But that's what you're going to have to do if you do this method as well. You're going to be taking 1.98 times 10 to the 22nd, multiplying it by 22.99, and then you're going to have to divide it by 6.02 times 10 to the 23rd. And if you put it into your calculator correctly, you should get 0.76 grams as your answer. So no matter what, we're always going to start with what we're given. So we're given 347 grams of CuCl2. And so if we use the conversion factor method, we want grams on the bottom. And then the key is to look for, what does it want us to find? How many molecules? So if I'm doing the cross multiply, I'm going to put X molecules on the bottom. So I want to find molecules, and I know grams. Well, again, we kind of have to do things a little bit differently here. We know that 1 mole is 6.02 times 10 to the 23rd molecules, and we know that 1 mole is equal to the molar mass. So again, we can use the fact that that would mean that there are 6.02 times 10 to the 23rd molecules in the molar mass of CuCl2. So we got to find the molar mass of CuCl2, which is 134.45 grams in each mole. So if I put that molar mass on the bottom so that grams cancels out, and I put molecules on the top, I can solve for that. If I put 134.45 grams on the top for the cross multiply method and 6.02 times 10 to the 23rd atoms on the bottom, again, I can solve for that X. So basically for the last problem and this problem, what we're doing is we're taking that 1 mole relationship and we're putting it together into a relationship that we now can see between molecules and the molar mass. And you should get 1.55 times 10 to the 24th power for the number of molecules. I've got in red the conversion factor method. You do need to write the correct formula for potassium phosphate. Potassium gets a positive charge. Phosphate gets a -3 charge. So we get K3PO4. The molar mass of that is going to be 212.26 grams. So again, in red, I have the conversion factor method, and in blue, I have the cross multiply method. Either way, you're going to be taking 0.91 and multiplying it by 212.26 to find out how many grams that would be. And you get 19.32 grams. So tomorrow we do have a quiz. So I've placed in the folder a practice quiz for you. So I'd like you to start with that right now in class. Do the practice quiz, and you'll be able to view your problems after you have completed it to see how you did. You do only get 1 practice quiz. And then you'll have time after that to work on the homework, which is a 1-page worksheet that I like you to do there. There are videos to review in today's folder if you would like. And of course, all of the videos that we've done all throughout this unit are posted in the folders for you to review as well.